So Chapter 7 deals with mainly strings. Okay, and characters is really a subset of strings, or actually a precursor to strings, right? A string is just a collection of characters. So I have a link here to most of the documentations if you want to look at for string, and then there it has a complete list of all the functions or methods that come with string and the string constructors. They have like a host of them, as well as some other fields and other operations in there. So this is for Java 8, so I think that's not the latest version in there. But let's look at string. Let's look at character, string, StringBuilder, and StringBuffer. So these two here are very identical. These two here, the StringBuilder, StringBuffer. I think the string, I forget which is older. I believe the StringBuffer is the older one, and the StringBuilder was created after that. But they are used for again, same thing, creating strings. These are called mutable strings, and then the actual string class is what's called the immutable, right? So we'll talk about that a little bit more. I think we discussed briefly way back from the beginning of the semester what immutable is and what's immutable and what's mutable. So we'll go over those. But let's look at character, right? A character is a class. Okay, so in Java it is a class called character, and you also have the option of creating very simple dynamic, very simple data types, right? It's called primitive data types in class. I mean, the character is one of them. It's called a char data type, along with the int and double and boolean and so on. All those are primitive types, but they also come with their own classes. So the character or the char is one of those. So when you create a character, okay, so I put these functions here. These are some of the built-in functions that are part of the character class. Okay, this is different from creating a simple data type like with a char. If you have a char which is a primitive type, you can't use these functions unless you use the class character class. So we have two ways to create characters, right? This is a typical way. Just char C is equal to single character A, and again in Java you have to use a single quote for character. You can only store one character at a time. So this is a primitive type. This is an object C1. As you can see, it has the keyword noon in there. Okay, it creates an instance of the character class, and even though it's an object of that class, you can still only contain one character per variable, right? So and when you use the character as a data type, then you can have access to these functions here. So if you want to change to uppercase, lowercase, check whether that character is a digit or not, or you can check whether it is either one of those a digit or a letter, right? So you use that to do a certain type of calculation, and for validation purposes. Maybe you want to say, like in the survey, for example, enter A or 1, right? And if you input other characters besides A or 1, then you can use this to check if it's true or not. Okay, so if somebody entered like a % sign or something like that, then this will return a false statement, right? A false value. So you only allow like letter and digits, right? Or you can be very specific, only characters or only digits. So very simple, just like that. The more interesting one is the string class. Okay, so string, as you can see, is one of the most popular ones out there in any language. Right? String, and usually string and integer type. Those two are like the most popular ones. So a string represents a character string, right? It's just a collection of characters. A string can be empty. That means if you declare a string with no text, nothing in there, like this, that's an empty string. Okay, that is different from if you set that to null, right? So it's different. So string literals in Java programs such as ABC are instances of this class called string class. Okay, and this is what is kind of confusing because also on the exam, which you guys did pretty good, is that I kind of have you do an input from the browser or from the user, and they input two strings called Java, and you test for equality, right? When you do something like that, then you notice that if you use the equality operator, they don't work because they're actually testing for the memory addresses instead of the actual values. Okay, and this concept may kind of confuse you because you may say, you know what, if I create two strings variables here, right? If I do this, and they're both A, B, C, if you compare them using the equality operator, actually you'll get the same string, which is going to be true. And then you might say, you mentioned that it's a string object you cannot create, you cannot test that way, right? So that's the confusion is. And to understand this, we have to talk about something called the string constant pool. Okay. So here again, there's two ways to create strings. One just the string literal, and then the other one is just the new keyword followed by the new string class, right? Common. So the string constant pool, this is what happens in Java. I'm not sure about other language might be different, but Java uses this concept here. So let's look at this diagram down here first. Okay, this is what's happening inside the system, especially in RAM, and in memory. This is thing called heap, right? So the heap is just basically in the RAM memory. So here's an example of showing you like 4 different strings. Okay, the first one here is a string object that is created using the new string. You assign the value or the text Java 5. Okay, and then when you use this feature with the new string here, what it does is that in memory, you're actually creating a variable, a memory address that is within the heap, and it's floating around in the wherever that is. So you have a memory address allocated for that string 1 object. Okay. So when you create a string just equal to some text, like the str2, that is a string literal, right? That's very common. We use that all the time. When that happens, as you can see, is this orange one here. It points to something called inside the string constant pool. This green circle here. Okay. So what it does is that if you use this method, string literal, then what happens is that Java the JVM will actually look into this pool, okay, and it will find if there is an object in there already that has the exactly same value as Java 5. Okay. If it doesn't have it, then it will create an object in there called whatever this is. This white circle here, oval here, stores the value of Java 5. And because there is a variable called str2 that is assigned or pointing to that value, then this object here has a memory address, whatever that is, ABC123, and that it points to that value, right? So it's in a constant pool. And then if you create another variable, let's just say str4 here, and stores the same value Java 5. Okay, because it's using the string literal again, so the JVM will go into the pool here, and it will look for a value of Java 5. If there is one, then yes, okay, there it is. So it will give the same memory address to this string 4. Okay, so that's why you're able to compare str2 equals str4, and you get the true value because they're pointing to the same memory address, right? So it's as if you actually compare the value, especially still the memory address of that object, which is this white object here, but because it's in the same pool, it is the same object. Okay, and then let's just say that if I reassign string 2 and string 4 to, let's just say, Java 6, then now this object is no longer being referenced, and so therefore eventually the garbage collector is going to come and destroy it, okay, from that constant. So that's how these constant pool works. So every time you create a string using the primitive, using this literal constant method, you always JVM always search inside this Java constant string constant pool first to see if there's an object in there. If it's not, it will create one. So you might have like a lot of objects in here that has some same values. So if you create like 10 string variables and they all have the same value, then all those 10 will just point to the same object, right? So it's just how it is. And if you change one of those to a different value, then since there's no text or string of Java, whatever 11, for example, then that new object will be created inside the constant pool, and then it will be referenced to or assigned to that variable until it's released or until another one assigns to it. Okay, so it points to the same memory address. So when you create a new string using a new keyword, like 1 and 3 here, so you're basically creating a separate object outside of this constant pool. So that's why when you try to use the equality operator, they will never equal, okay? Because the memory addresses are completely different, separate. And that's the case when we have like you're reading input from the console. When that happens, it actually goes into the heap here as a separate memory address, and that's why they'll never be equal because of the memory address. And if you want to test for the actual value, then you use the equals operator or equals function to test for the values, right? So this is what's happening behind the scene in Java when you use these two methods here, using the string literal or the new string function. And this is not only for string. When you, every time you create a new something, a new class of your own, it will always be the same thing here. So in the heap, JVM will create a new instance or a new object in there for you. Okay, until you change. Let's just say that string 2 is equal or assigned to string 1. Then when you do that, they actually point to the same object, right? So when that happens, it's like same thing going to this constant pool here, but it's in heap area. Okay, so that's the difference between strings, how you instantiate them using the new keyword and using the string literal constants. Okay. Yeah, I'm just going to explain what that is. And the book also shows something a little bit about that as well. So again, it just shows you that this is the memory address of the word hello, text hello, and this is a different text, so therefore it has a different memory address, and both of these are actually stored inside that constant pool, right? Because the way they're assigned here, created here, you're creating using the string literal method, so you will have two of these objects floating in the constant pool. Same thing over here, you have two of them. So if greeting is now initially it points to a hello right here, and then after that you change it to a new word. So when that happens, you actually create a new object out of that in the pool, and then it points to that new object now. And so this one here has lost the reference. So in like for I don't know how long that is it's going to take, but eventually the garbage collector is going to come and remove this from the memory. Okay, so it will be recycled. And the memory address will be recycled back again. So the thing about string is that it's not mutable, it's immutable. What that means is that every time when you create a string like this, a string, a variable a greeting is equal to hello, right? This line here will actually be created inside into the constant pool. Okay, it recreates it every time, and then if you write the next line and we assign that to a new value, then, I mean, for us, we think that it's the same variable name. It should be the same variable name, the same memory address, and that's not true. Okay. Every time you run a single line, you reassign a value to a string, it always recreates it again and again in memory. Okay. Every time. That's why it's called immutable, right? You cannot change its data. You have to recreate the whole thing again, even though we're using the same variable name. Okay, and that is different from StringBuffer or StringBuilder. Those are immutable, and those will retain the memory address. You just change the value. Okay, so the reason why a string is immutable is because when it follows these rules here. I should put this down here so we can see those 3 bullet points. Do that. Okay, you see these 3 bullet points here. A class, if you want to create an immutable class, then you have to make sure that they meet these 3 main qualifiers here. So all the fields must be private, right? Of course, we'll usually create private fields, and there can't be any mutators in there, right? Mutator means like the getter, right? No, I mean setters. You cannot have setters, so you can't set data. So therefore, it's only like it's almost like read only, and because it's private, and you also have the class set to have the final modifier. Okay, so it's a final class, so that's why you cannot change its value. So when you create something, it's like a constant, right? A constant variable. You can't change its value. The only way to change it is you have to recreate it again, right? That's the only way. And the class allows you to do that. So if you look inside that class, see if I go back here, I'm just going to load this link very quickly. You can look at. Okay, this is in the Java documentation. You will see that inside the class declaration or definition, it's a public final class called string, right? So it's final. That means it's immutable. You cannot change its value. That's why when you create a new variable, or even the same variable with a new value, it gets recreated again every time when you run your code. Okay? All right. Let's see. So a string is immutable. The string class. So again, I mentioned that when you create an object string str1, assign a variable to this value here, labird. It looks into the pool. If there's not already a string text called labird, it will create that object, and then assign that memory address to str1. Okay, until you change it like this. Then now, because this is now a different string, it's no longer labird, then this will be destroyed because now it's not being used. And then now str1 is recreated again with a new memory location that points to this new text. Okay, that's happening behind the scene. Same thing here. So this one is interesting because we use a new string, right? No values assigned to it. And now this is a new object, but as soon as you assign it with a variable value this way using the StringBuilder method, then it's the same thing as going back to here, even though you created with a new string object here, because you pointed to a constant. That constant is actually inside the pool. So it points to the object in the pool, so therefore now the memory address is pointing to that same pool. So you can still compare str2 to str1 if it has the same value or not. Okay. And this one here, string3, you create with a new string, but the value you pass to it through the constructor, and then now this is in an object in the heap. Okay. So if you compare s2 to s3, it won't work because they're pointing to 2 separate locations. Okay, so StringBuilder and StringBuffer. These two are what's called the mutable classes. Okay, and one is different from the other mainly because of something called the single-threaded and multi-threaded processors. Right? I'm not sure if you're familiar with that, but that is a mechanism where some languages allow you to create multiple threads that run at the same time, and it's like you have several layers of languages or a program that run at the same time, and they able to manipulate the same variable inside your code, right? So the string builder is usually you use that for a single threaded program. That means one processor that runs your program right from top to bottom. So it's much faster to create and to build, but then it's not safe. It's not thread safe. That means if you were to use a string builder inside a multi-threaded program, just like you have a variable name called name, and that name has the value of John. Okay, and because you have like multiple threads, you can have like two threads that have access to that same variable called name. Thread A might change that already, and then thread B thinks that it's still John, but it's not John anymore, right? So thread A might change that to Spencer, and now thread B is thinking that it's still John, still treat that as John, and then but it's not true anymore, okay? Because you can change the value for string builder and string buffer. So that is mainly the only difference between the two. Okay, it's mutable. It's not thread safe. If you write a multi-threaded program, like a program that has a lot of multiprocessors, this is for parallel programming, then you want to use the string buffer instead of the string builder. Okay, so it's thread safe. Each one is it's designed for that purpose. Okay, but they're both immutable. It's a sequence of characters, just like a regular string. And then another difference between them and the string class is that these are their memory address don't change. Because once you create them, they will retain that memory address. It doesn't matter what the values are. You can change the values, but the memory address will always be the same until you destroy it, right? And that is the major distinction between a string and them, these two. So for example, if you create a string builder called str4, and you have to use the class to build it, right? You cannot just say string builder str4 equals John. Okay, it doesn't work. So you have to instantiate it first, or you can pass the value directly into it in the constructor, I'm pretty sure, and then it will create a string str4 has the value of whatever it is. So when you add string to it, actually this is incorrect. This shouldn't be add, it should be append. Okay, I think yeah, there should be append. I don't think there's an add class. So when you want to add string or values to the string 4, then you need to use the function or the setter called append. Okay, you append it, it will be appended to the end of that list, which is very similar to Visual Basic, the list class. So the list.add, keep adding to the end of that list only. And if you want to add into a certain spot, then you can use the insert function instead. So insert you can use like string4.insert, and then you put the location and then the values. It will insert in that location. Okay. So when you append these together, like you have welcome to Java, and they have a space, appended space, append the next word, append this one here. When you print it out, you actually have just a single string. Okay, even though you added separately like that, it's keeping appending to the end of that string, so you have like it's a long string. Unlike Visual Basic, you have the list box. You have actually a different collection of, it's like a different field, but in the string, just one long string. If you were to find the length of that string 4, then it will count everything from the word, the letter W, all the way to the end of that second exclamation mark. It will give you the length of that string, right? And these are just some, a comparison between the string and string buffer, how they're different from each other. Again, string is immutable, and so on. And then down here is between the string buffer and the string builder, right? And some more information here as well if you want to look into that. But I mean, we're not gonna go into like threaded or multi-threaded programming. But that's like advanced stuff. So I'll just let you know their differences. And then we have a lot of these built-in. Yeah.
So for content table or system with three, so I can have a string class overrides the equals method. Does that mean that you can't use it as a string buffer object?
The string buffer doesn't allow.
This doesn't override the equals method of object class.
Well, yeah. This equal method here is part of the object class. Okay. So in the string, I mean, this is not something that you override. This is something that the string class itself overrides. Okay. So in the object class, you have a function called equals, and because both string and StringBuffer and StringBuilder, they all extend the object class. Okay. And then in the string class itself, it actually overrides the equals function from the object class. So you can use that equals inside the string class, and if it's override, I'm curious if it's overridable. I think you can actually override it, because if you create a class of your own class, and if you extend the string class, then you can override the equals. Okay. Whereas if it's a string buffer, you can't.
Does that mean you can't use the equals method then for the object?
You can use it, but like in the string class, you can have your own way of implementation if you want to. But the buffer doesn't let you do it. So the string buffer will use this equal function, which is a part of the object class only. So whatever the object class has, you are limited to that implementation. So the string, you can override it with object class, and the buffer you can't. But you can still use that to equate to string variables. Okay, so the link I showed you here has a lot of functions you can explore. So all these are different constructors. Okay, and they have a lot of methods here. All the methods are listed here, so it's a lot of them. Okay, I'm not going to go through all of them, but some of the common ones you'll see, I put them here. You can check for empty string or not, right? If the string is empty, it will give you a true or false. You can check for the length of a string. It will give you the number of characters of strings. A white space is a character, so that is also a part of the length. And you can check for if you can convert to lowercase or to uppercase. Okay, and the way to use it is, remember these are functions, right? Function, and to use that, you could just say whatever this variable is, that to lowercase, that to uppercase, right? Like that to of dot length, that is empty, right? You're checking the object or the variable name, and then of course you call that function. So uppercase trim here is just what it means. You trim the white spaces around the text at both ends. I don't think it has trim left and trim right like Visual Basic does, but it trims the entire space around both of those. Concat is to join two strings. Okay, and then you pass the second string here. So the first string dot concat second string. So like this, if you have the first string is chars, and then concat that with the s, you get chars, right? So then to concat get is concat her is together, right? You can do that. You can use the dot or the method chaining to concatenate those. You can keep going if you want. Okay. The replace character is also really interesting. If you want to replace a certain character in your string, then you can use that as well. It takes two parameters, the old character and the new character. Let's just say if you have a string called like this one here, right? Or even like word of variance. You replace, looks for all the E's, replace those with O, replace all the R's with Y, and so on. Okay. The substring has like I just put two here, but you have like several options in there. These are just probably just the most common ones. You want to return the substring beginning with the position of index 2, right? So if you look at the word unhappy here, this is the first index, second is at, and after that, then you would start at that 2, which is the H, right? This is position 0, position 1, position 2, and then from 2 all the way to the end of that string, you return that, so you get happy. Okay? So it's the index position, starting with that all the way to the end. This one here is kind of the same thing, except you put a limit to the end of that index. If you don't put the second parameter, it's going to read all the way to the end of that string, however long that is. If you supply the second parameter, then you put a limitation to how far where you want to stop based on the index. So I'm starting at fourth index, so 1, 0, 1, 2, 3, 4 at the letter U, and then I'm going to go and stop at index 8. 4, 5, 6, 7, and then 8 is not inclusive. The way it does it doesn't include the 8th ones, but it will stop there. So you get the word urge out of that. Okay? And then 5, if it's longer than what you have, then it's going to go all the way to the end of the string. Okay? So if you have just the word TO, and you say from 1 to 10, then it's still going to give you that, just the word O there, letter O there. And then you have the starts with. This is pretty straightforward, self-explanatory. Start with a character, or start with a sequence of characters. Okay, it doesn't have to be one. It could be like APP, right? Any word that starts with that, then will return true. And it ends with is just the opposite, right? It must end in a certain character or a sequence of characters, and it returns true or false. Okay. The character at or the char at, and then you give the index of that string, will return a character of that location, right? Again, this is a single character. So the word apple here, if you want to return the second character at the second index, index of 2, then you get the word character P here. This is 0, 1, and then 2. Get a P out of that. Okay. The split is very similar to other languages like Visual Basic, JavaScript, PHP. All use the same method here. So you take a string and you split it using a special character, right, or a sequence of string, and if it matches that expression or that sequence, then it will use that as a location to cut the string. Okay, once you split it, then it will return back an array of those elements inside the string. Okay, so for example here, let's just say the string has the word Java, that is a string, and if you want to split in here using a single space character, then it will look for that string every single character until it finds a space. If it finds that, it will use that as the location to split it, so it will cut there, and so it will cut into two strings in this case, right? And then you put Java in the first element, so here Java is the first location, and then it continues on to the next one. It finds it again, another space, breaks that, puts it into the second location, and then you keep going until the end of that. Okay, so you have white space, and this is very useful for if you want to parse, a text file or a list of items, and you want to parse those and break those into an array. Like especially useful for reading some like CSV file that has it's a comma separated or you separate whatever, put the semicolon or something, then you put that special character here, it will do that for you automatically. So the array, so you assign that to an array called words, for example, and you don't have to specify the length of that array. Usually you have to, but in this way you don't, because Java will manage it automatically. It will determine the size for you based on the number of splits you have in here. So that will be assigned dynamically by Java for you, so which is pretty cool. And once you have that created, then you can iterate through that words array. And this is a loop that we haven't touched on yet. It's called the it's a for loop that is used primarily for arrays. And you will look for, you will split every element in here. So this way you can say for the string type called word, it's a variable called word. That means inside the words array. So for every word in the words, this is also called the for each, or more commonly called the for in array. Okay, so it's like for each word, just a variable name in the words array. So this array must already existed, and then you could just get the word out of that, or the element, each element this way. So this is a for loop. Actually, I should close that one here too. And if you output that, then you'll get something like this. It's very, very useful. Down here is the value of. This is also very similar to the char at, right? The character at. Well, no, not character at. It's different. This is just a way of reading the output or the value of a string. If you're using like both the StringBuffer and StringBuilder and string, actually applies to all of them. So you can get the value of string index string, for example, has the word apple. If you use that value of that string, you get the word apple. Same thing, just saying, same as saying string out, system output print, then index string. You get the apple out. Index of, this is kind of similar to the char of, except this one you get the index position instead of the character, right? So the character will return the character, index will return the position of that word or that string in this string here. It's like a substring, if it has one. If it doesn't, then it return a value of -1. Okay, that means it doesn't exist. Equals, we talked about that already. You can create objects in there, and you have equals ignore case. Okay, so the equals here, it cares about case. Okay, so if you have like a uppercase A and lowercase a, they're not equals, you get false for that one. If you want to ignore case, then use the equals ignore case, right? Just like that. And it would use, the way you use it is very similar. Just the first string equals ignore case, the second string, and then you check whether they have the same value or not. So when that happens, then true or false. That's one way. If you want to make sure that is also taken care of, then you will convert these to either all upper or all lowercase, right? So you don't have to worry about case. But that's another very common, very useful method. And then the toString here, this is a special method that you can actually override in any object, any class you create. This one here is basically, it prints the string representation of an object. So notice if you have an object, if you print it out, usually you have with some strange numbers, and those are what's called the hash code, which is the memory address of that object. But usually you can achieve that by overriding in your code the toString function, and then you can output a more meaningful string message. So I have an example here. Let me just put it to the next screen. So for example, you have like if you don't have if you don't have this string method here, if this was not inside the pet class, okay, and when I instantiate a pet called P1 with the new pet body in 4, and if you just print that out, right, you're going to get something very strange. It's going to say string 1 @ symbol some numbers. Okay, it's not going to give you the nice output because it's trying to print something, but you don't have that format. So it's going to print actually the memory address or the hash code for that object P1. Okay, if you want to read something, produce something nicer, then you can override that toString in the pet class, and then in there you can rewrite it so that if you want to just show the object information, then you can write something like this, whatever you want, right? You return the string back to the caller, and that way you will print the actual data and not the memory address to the console. And we'll do some example in there. And then I think finally here, I'll just show you some conversion. It's a little bit tricky to do that because when you have a character called letter A and you want to use that in the string, you can't just say string S is equal to C. Okay, it doesn't work because you have a different data type. And to convert it to a string, you have to use the character class. As you can see, the class dot toString. This toString is this one here, right? I just showed you. It has its own toString, and then you pass in the variable or the string, right? In this case, it's C or the letter A. If you do that, then now it will become a string for the string S. Integer, if you want to convert this to a string, same thing. Use the integer class, right? So there's a character class. There's also an integer class. There's a double class. There's a byte class. There's a Boolean class. Okay, they all have those classes. Only those classes will have the toString or other built-in function you can use. Okay, if it's like a primitive type, if you use the letter C here, there's no function built into it. So you don't have like dot C dot toString. It doesn't have that. Okay. So just show you a few conversions here. Okay, so I think that's pretty much what I wanted to cover for the string chapter.